What if the steering wheel in your hands isn't actually connected to the car? Not metaphorically, not conceptually, physically. What if, for over a century, the single most important control system in automotive history has been nothing more than a mechanical illusion, a spinning circle, a steel rod, a system you were told you could trust with your life? But what if that trust was misplaced? Because somewhere, quietly, engineers have already removed it and replaced it with something invisible, something digital, something you cannot see, touch, or control. Stay with this, because by the end of this video, everything you thought you understood about driving will collapse. Destruction of belief. For over a century, the act of driving has been defined by one simple, unquestioned principle: turn the wheel and the car responds. A direct, physical connection. Human input translated into mechanical motion. Steel, gears, and force working together in perfect, predictable harmony. This wasn't just engineering, it was trust. Entire generations were raised on this idea. Driving schools taught it. Manufacturers built their identities around it. Engineers refined it, perfected it, defended it. The steering wheel wasn't just a component, it was the control, the proof that the human was in charge. But here's the uncomfortable truth. That belief was never as solid as it seemed, because buried beneath decades of refinement was a system that had barely evolved. A rigid mechanical architecture carried forward from the earliest days of the automobile. Heavy, inflexible, bound by physical limitations that engineers quietly learned to work around instead of solving. And for years they told the world it was the only way, that nothing else could be trusted, that nothing else could be safe. They were wrong, exposing the old system. At its core, the traditional steering system is brutally simple. A steering wheel connected to a solid metal column. That column linked to a rack. That rack pushing the front wheels left or right. It's direct, mechanical, predictable, and fundamentally primitive. Because this entire system depends on one thing: force traveling through metal. When you turn the wheel, you are not commanding the car. You are physically forcing it to respond. That means friction. That means resistance. That means delay. Every movement has to travel through joints, gears, hydraulic fluid. Every component introduces latency. Tiny imperfections. Energy loss. It is not instant. It is not precise. It is a compromise. And then there is the darker side of this design. That solid steering column, the same one that gives you control, becomes a lethal spear in a high-speed collision. For decades, engineers have been forced to design around it, adding collapsible sections, safety mechanisms, trying to mitigate a problem that exists only because the system itself is outdated. And yet, it remained. Not because it was perfect, but because no one dared to remove it. Introducing the disruptor. And then, something changed. Not gradually, not evolution, a rupture. Somewhere inside a new generation of electric vehicle platforms, engineers stopped asking how to improve the steering system and started asking a far more dangerous question. What if we removed it entirely? No column, no rack, no physical connection between the driver and the wheels. At first, it sounded like engineering heresy, a violation of everything the automotive world believed to be sacred. But while legacy manufacturers hesitated, protecting decades of mechanical heritage, others moved forward, faster, more aggressively, unburdened by tradition. Enter steer-by-wire, a system where the steering wheel is no longer a mechanical device, but an input device, a signal generator. When the driver turns the wheel, nothing physical moves beneath it. No gears engage, No shaft rotates. Instead, sensors capture the motion, convert it into digital signals, and transmit those signals to electric actuators at the wheels. The car doesn't receive force anymore. It receives instructions, and those instructions travel at the speed of electricity. This is not an upgrade. It is not a refinement. It is a complete architectural reset. The moment the mechanical link disappears, the entire definition of driving begins to change. Technical breakdown, the core technology. To understand how radical this shift really is, you have to look beneath the surface. Because once the mechanical connection is gone, something else has to replace it. Not just in function, but in trust. At the heart of a steer-by-wire system is a simple idea. Remove force. Replace it with information. When the driver turns the steering wheel, a network of high-precision sensors immediately captures that movement. Angle, speed, direction, even micro-adjustments measured in fractions of a degree. That data is converted into digital signals, not physical motion, not torque, pure information. Those signals are then sent, almost instantly, to a set of electric actuators mounted at the front axle. These actuators don't translate force. They generate it, independently, precisely, on demand. There is no shaft connecting the two ends, no mechanical dependency, no delay caused by friction, fluid, or inertia. Instead, the system operates on feedback loops. Every input from the driver is matched with real-time data from the car itself. Wheel position, road conditions, speed, load distribution. Sensors constantly feed this information back into the control unit, adjusting the steering response dynamically, hundreds of times per second. What you feel through the wheel. That's not physics anymore. It's simulation, artificial resistance, artificial feedback, carefully engineered to mimic what used to be real. And that's the unsettling part, because for the first time in automotive history, the feel of driving is no longer mechanical. It's software. Technical breakdown. Performance domination. Now here's where things stop being theoretical and start becoming uncomfortable. Because once steering becomes digital, it is no longer limited by physics. It is limited only by code. In a traditional system, the relationship between the steering wheel and the front wheels is fixed. You turn the wheel a certain amount. The tires respond in a predictable mechanical ratio. It cannot change. It cannot adapt. It cannot think. But in a steer-by-wire system, that relationship becomes completely fluid. At low speeds, the system can amplify your input, turn the wheels aggressively with minimal effort, allowing a large vehicle to pivot with the precision of a compact city car. At high speeds, it does the opposite. It dampens your input, stabilizes the car, prevents oversteer, filters out human error before it even reaches the road. The ratio isn't fixed anymore. It's calculated, in real time. And the response? Instant. No hydraulic lag, no mechanical slack, no energy loss through metal components. Traditional systems rely on pressure building inside fluid lines. This system operates at the speed of electricity. The difference is not subtle. It's surgical. But the real shift isn't just speed, it's control. Because now, the car doesn't just respond to the driver. It interprets the driver. It can smooth out abrupt movements, correct instability, even override unsafe inputs entirely. And that raises a question most drivers aren't ready to confront. If the car is correcting your actions, are you still the one driving? Technical breakdown, engineering advantage. The moment you remove the steering column, something profound happens. You don't just change how the car drives, you change how the car is built. Because that long, rigid metal shaft, running from the steering wheel through the firewall into the front axle, has dictated vehicle architecture for over 100 years. It carved a permanent path through the chassis, forced engineers to design around it, protect it, reinforce it. Now, it's gone. And suddenly, that entire section of the car opens up. The dashboard no longer needs to accommodate a fixed column. The driver's position becomes flexible. The cabin layout can be reimagined. Seats can move, rotate, retract. The front of the vehicle becomes less of a mechanical compartment and more of a digital space. But the real advantage isn't comfort. It's safety. In a traditional car, the steering column is a structural liability. In a high-speed frontal collision, it becomes a rigid object aimed directly at the driver's chest. Engineers have spent decades trying to make it collapse, bend, absorb energy, anything to reduce the damage. Steer-by-wire eliminates the problem entirely. No column, no intrusion, no mechanical spear. And beyond safety, there's weight. Removing the entire mechanical linkage reduces mass, simplifies assembly, eliminates dozens of components, joints, bearings, fluid systems, fewer parts, fewer failure points, greater efficiency. This isn't just better engineering, it's cleaner. A system stripped down to its essentials, force replaced by signal, metal replaced by code. And once that transition happens, there's no reason to go back. Technical breakdown, extreme capability. This is where the conversation becomes uncomfortable, because the first question everyone asks is the same. What happens if it fails? If there is no physical connection, no backup shaft, no mechanical fallback, what happens when the system goes dark? In a traditional car, failure is gradual. A worn component, a leaking hydraulic line, a stiff steering feel. You feel it, you adapt. But in a fully digital system, failure is binary. It works, or it doesn't. And that sounds terrifying, until you understand how these systems are actually built. Because steer-by-wire doesn't rely on a single line of control. It relies on redundancy. Multiple sensors track every input, multiple processors verify every signal. Multiple power systems ensure continuous operation. If one system fails, another takes over instantly. Not in seconds, not in milliseconds, in microseconds. This is not automotive engineering anymore. This is aerospace logic. The same philosophy used in modern fighter jets, fly-by-wire systems that have been trusted for decades, at speeds and forces far beyond anything on the road. And then there's something even more unsettling. Because once the system is fully digital, it doesn't just react to failure, it anticipates it. It can detect anomalies before they become problems. Correct instability before the driver feels it. Maintain control even when physical conditions would overwhelm a human. There are already demonstrations of vehicles maintaining stability after catastrophic scenarios, loss of traction, uneven load distribution, sudden mechanical disruption. Not because the driver saved it, but because the system did. And that changes the equation completely. Because now the question is no longer, what happens if it fails? The real question is, what happens when it performs better than you ever could? Technical breakdown. Future implication. And this is where the line disappears. Because once steering becomes software, it no longer belongs to the driver. It belongs to the system. At that point, the steering wheel itself starts to lose its purpose. Not immediately, not visibly, but structurally. It becomes optional, because if input is just data, then input can come from anywhere. A wheel, a joystick, a touch interface, or nothing at all. In a fully autonomous mode, the steering wheel doesn't need to exist. It can retract, fold into the dashboard, disappear entirely, not as a design feature, but as a logical consequence. There is no reason to keep a control device for a human, who is no longer required to control the machine. And this is where steer-by-wire stops being about steering. It becomes the foundation for autonomy, because without a mechanical connection, the system can take over seamlessly. No resistance, no conflict between human input and machine decision. Just a continuous stream of commands executed with absolute precision. And once everything is defined by software, everything becomes changeable. Steering feel, adjustable. Response curve, programmable. Driving dynamics, downloadable. The personality of the car is no longer engineered in metal. It is written in code, updated over the air, refined continuously, controlled remotely. And that introduces a reality most people aren't ready to accept. Because if driving is just software, then control is just permission, granted or revoked. Humiliation of legacy. Now place this system next to what the traditional automotive world is still defending: a mechanical steering column, a rotating metal shaft, a design philosophy that hasn't fundamentally changed in over 100 years. And suddenly, the contrast becomes impossible to ignore. Because while modern digital systems are operating on instantaneous signal processing, adaptive feedback, and predictive control, legacy manufacturers are still refining hydraulic pressure curves, still optimizing gear ratios, still polishing a system that was born in the era of horse-drawn carriages. They call it heritage. They call it driver engagement. They call it purity. But strip away the branding, the nostalgia, the marketing language, and what remains is brutally clear. It is outdated. A system bound by friction, limited by physics, restricted by mechanical constraints that no amount of refinement can eliminate. And the most uncomfortable part? They know it. Because the same companies that publicly defend mechanical steering are quietly investing billions into digital architectures, developing their own steer-by-wire systems behind closed doors, testing, iterating, preparing, not because they want to, but because they have to. Because once a fully digital system proves itself, once it demonstrates superior precision, safety, adaptability, there is no rational argument left. You cannot defend slower response times. You cannot justify unnecessary mechanical complexity. You cannot convince a new generation of drivers that feeling the road is more important than eliminating risk. And yet, they try. They wrap it in emotion, sell it as tradition, frame it as something that should be preserved. But when you place a legacy vehicle next to a fully digital platform, the illusion breaks. The old system doesn't feel refined. It feels heavy, delayed, crude, like operating a machine that belongs to a different century. This is no longer a competition. It is an exposure. And for the legacy manufacturers, it is a slow, public realization that the very thing they built their identity around is becoming irrelevant. Geopolitics. And this is where the story stops being about engineering and starts becoming about power. Because the shift to steer-by-wire is not happening in isolation. It is part of a much larger transition, one that is quietly redefining who leads the global automotive industry and who is falling behind. For decades, the West dominated this space. Germany, the United States, Japan. Nations built on mechanical excellence, precision manufacturing, heritage. But that dominance was built on a specific kind of expertise, mechanical engineering. And now that foundation is being challenged. Because steer-by-wire is not a mechanical problem, it is a software problem. And in that domain, the balance of power begins to shift. Chinese manufacturers, unburdened by legacy systems, uncommitted to decades of mechanical tradition, have moved aggressively into fully digital vehicle architectures. Electric platforms designed from the ground up to integrate software, sensors, and high-voltage systems without compromise. They are not adapting the old model. They are replacing it. Meanwhile, in the West, the response has been hesitant. Regulatory bodies raise concerns about safety. Governments debate standards. Legacy manufacturers move cautiously, balancing innovation with the risk of disrupting their own business models. And behind that hesitation, there is something else: fear. Because once these digital systems reach mass adoption, the competitive landscape changes overnight. The advantage no longer belongs to those who mastered gears and hydraulics. It belongs to those who control code. And code scales. It evolves faster, improves faster, dominates faster. This is why tariffs appear, why restrictions tighten, why the narrative becomes political. Because this is no longer just about cars. It is about who controls the future of mobility. For over a century, the act of driving has been defined by something you could touch. A wheel, a column, a physical connection between human and machine. That era is ending, not slowly, not eventually, but right now, because once control becomes digital, it is no longer bound to the driver. It is defined by the system, shaped by software,
in the steering
governed
wheel
by
recreate
something
road
far
feel,
more precise
simulating resistance and
far less
feedback,
human.
stability and performance.
The steering
It
wheel
delivers
is not
tight,
evolving.
direct control for
It is
parking or city
disappearing.
driving. Is
And with it,
impossible in purely
the
mechanical
idea that
systems.
you are
Without
in
a steering
control.
column,
The
car makers
old
can
world,
reconfigure
built on
cockpits,
metal,
ink lane
force,
changes,
and
and
mechanical
future
certainty
autonomous functions.
is already collapsing.
However, there are trade-offs.
What
Road feel is
replaces
simulated
it is
effectively.
silent,
Already use steer-by-wire
invisible,
technology. The Tesla
ruthlessly
Cybertruck
efficient,
uses a full Bosch and
it does not
ZF
need
are
you.
pushing the technology
This
for
is
adoption
drive
across
and
your mechanical to
RPM.
software-defined steering.
If you want to
It offers
understand
tunable
the technology
performance,
that
flexible
is
interior. The
rewriting
ultimate
the rules
test
of
is
the
whether
road
drivers are ready to
before it
trust a
rewrites
fully
your role in
electronic
it,
connection
subscribe,
between their hands.
because the future isn't coming. It's already here.